In section 6.4, we're going to look at something called sampling distributions and estimators and see how they relate to normal distributions. Suppose we roll a die 5 times and we found the mean, and let's say we found the mean to be 3.4. And we'd say x bar was 3.4. And keep in mind, finding the mean is just adding up the values that we get on each of those 5 rolls and dividing by 5. So let's say then we did this again. We rolled the die 5 times and we found the mean. And this time we found it to be 4.1. And we did it again, and again, and again. And each time we got a different mean, on and on and on. Well, what we could do then with all these means, we could find the mean of the means. And that would have a mean itself, a population mean of 3.5. So when we talk about the sampling distribution of the mean, we're looking at the means of all the different samples that we're taking and how they're distributed. And they'd be distributed about a mean of 3.5. The sampling distribution of a statistic is the distribution of all values of that statistic when all possible samples of the same size n are taken from the same population. More specifically, what we were just talking about, the sampling distribution of the mean, is the distribution of sample means with all samples having the same sample size n taken from the same population. So with our dice rolling example, we were finding the sample means, and each sample had the same sample size of 5. So we rolled the die 5 times in each sample. So we could talk about the sampling distribution of those means. This suggests that where we talk about sampling distribution of a statistic, there must be some other statistic other than mean that we're going to talk about. So the other are going to be variance and proportion that we're going to talk about, the sampling distribution of those in a moment. So back to our dice rolling example, we say that these sample means target the value of the population mean. So the population mean is 3.5, meaning on average you would expect to get about 3.5 if you did this over and over again. We say these sample means target 3.5 in a sense because they kind of close in on 3.5 as you do this over and over and over again. The distribution of these sample means, so if we laid these sample means out, the distribution of these sample means would be a normal distribution around the population mean. So the mean of these means would be 3.5. So let's think about the sampling distribution of the variance. This is the distribution of sample variances with all samples having the same sample size n taken from the same population. Let's take a look again at the die rolling example. Let's suppose we rolled the die 5 times and this time found the variance on each of those. So let's suppose the first one we found the variance to be 2.7. The second one we calculated the variance to be 1.9. And keep in mind, each of these represent rolling a die 5 times and finding the variance of those 5. So we've done that twice now. We'll do it again, and suppose we found the variance to be 3.5, 2.6, etc., etc., etc. Well, it turns out when you talk about rolling a die, the population variance, or the variance you'd expect to come up, would be 2.9. And we say the sample variances target the value of the population variance in the same sense that the sample means target the population mean. Also, the distribution of sample variances tends to be a normal distribution. So if we laid all the sample variances out, we would see that bell-shaped curve. Let's think about this in terms of a proportion. Now the sampling distribution of the proportion, same as the mean and the variance, is the distribution of sample proportions, with all samples having the same size n. So if we roll a die 5 times again, and this time let's find the proportion of odd numbers. That is, out of the 5 rolls, we'll count up the number of times an odd number comes up and divide that by 5. That gets us the proportion of odd numbers. So in this case, suppose that one odd number came up out of 5. Then our sample proportion is 0.2. And if we do this over and over again, we'll get different proportions on each of the 5 rolls. If you think about what you'd expect to have happen on 5 die rolls, you'd expect about 0.5, half of the rolls to be odd. Just as with the mean and variance, the sample proportions target the value of the population proportion. So these sample proportions are going to be closing in around the population proportion, 0.5. And just as before, the distribution of these sample proportions, if we laid all these out, would tend to be a normal distribution and have that bell-shaped curve. The sample mean, variance, and proportion are called unbiased estimators of the population mean, variance, and proportion respectively because they target the population parameter. The sample median, range, standard deviation are called biased estimators of the population median, range, and standard deviation